Have you ever wondered how science managed to discover its natural laws, principles, and theories? Or how technologies keep up with the gadgets we want and need? How do sociologists know about past civilizations and social behaviors? You are now watching Psychopunks, and today we will talk about the scientific method.
First, what is scientific method? Scientific method is a process of sequence of activities undertaken to gather information and to come to conclusion about the natural world. It is foundation of scientific inquiry used by scientists to gather and analyze data to test hypotheses and theories. In other words, the secret to how scientists, technologists, sociologists discover groundbreaking results, products, and answers is through the use of scientific method.
Scientific method consists of 5 important steps, namely observation, formulation of hypothesis, testing of hypothesis, experimentation, and drawing of conclusion.
The first step in the scientific process is making observation and gathering knowledge about a phenomenon. Observation involves using our senses to gather information about the natural world. It requires initial observation, recognition of a problem, and defining it, further observation, and expanding knowledge.
For example, you may observe that your plants are not growing as well as they used to, or that there are fewer birds in your backyard. Another great example is when Isaac Newton observed an apple fall, became so curious,
and decided to discover more about just the observed phenomenon.
Next step would be the formulation of hypotheses. Scientists use reasoning to come up with a hypothesis, which is defined as an intelligent guess that is a possible explanation for a natural event. It must be presented as an actual statement and must be testable.
Hypothesis uses 2 types of logic, inductive logic and deductive logic. Inductive logic involves specifics to generalization, while deductive logic proceeds from a generalization to specifics.
For deductive reasoning, imagine this. You heard that all CAS faculty teachers are intelligent. Your STS teacher is one of the CAS faculty teachers. Therefore, your STS teacher is intelligent. The inductive reasoning is just the other way around.
The third step in the scientific process is experimentation. This involves designing and conducting experiments to test the hypothesis. The experiment should be designed in such a way that it can either confirm or refute the hypothesis.
It doesn't really have to be experiment where chemicals, microscope, and laboratory apparatuses is involved. It can be done by simply assigning a control group and an experimental group, wherein the experiment group receives the treatment, whereas the control group receives none.
Imagine this. You observe that whenever you drink coffee, you always get a perfect score in an exam. You may want to test this by assigning a control group who will just take the exam, while the experimental group will drink coffee before the test. Then see which group had a higher score.
The last step in scientific process is drawing a conclusion. This involves using the result of the experiment to draw a final conclusion about the hypothesis. The conclusion should be based on the evidence gathered during the experiment. In our little experiment earlier, if we discover that the experimental group had a higher score than the control, then we reject the null hypothesis and conclude the coffee has a significant effect on the performance of the participants. Conclusions from many different but related experiments may lead to the development of a scientific theory, which is defined as a general concept about the natural world. A theory, therefore, is a hypothesis that has been repeatedly and extensively tested and always found to be true. But always remember, Psychopunks, as stated by Keaton and McFadden in 1983, scientists should be ready to alter or even abandon their most cherished generalization when facts contradicts them.
Today in Psychopunks, you'll learn that scientific method is used by scientists to test their ideas and theories, which led to many important discoveries and advancement in various fields of study. We also studied the steps in the scientific method, which comprises of observation, formulation of hypotheses, experimentation, and drawing of conclusion. You also learn about inductive and deductive reasoning as well as the scientific theory.
Today, we are going to explore the question of whether classical music performs better than rock music. To answer this question, we're going to use scientific method, which involves making observations, forming hypotheses, designing experiments, collecting data, and drawing conclusion based on that data.
First, let's start with the observations. We know that classical music and rock music are two different genres that have been around for quite some time. We also know that people have different preferences when it comes to music, and that there are many factors that can influence which type of music people prefer.
Based on this observation, we can form hypotheses. Classical music performs better than rock music in terms of its effects on cognitive function, moods, and stress levels. To test our hypothesis, we need to design an experiment. We will gather a group of participants and randomly divide them into two groups. One group will listen to classical music, while the other group will listen to rock music. We will then test each group cognitive function, mood, and stress levels.
To collect our data, we will use a variety of tools and tests, such as memory tests, mood questionnaires, and stress scales. We will also take note of any other factors that may influence our results, such as age, gender, and musical background. After collecting and analyzing our data, we can now draw our conclusions. If our hypothesis is supported by our data, we can conclude that classical music does perform better than rock music in terms of its effect on cognitive function, mood, and stress levels.
In summary, using the scientific method, we can investigate and answer questions about the world around us. By carefully designing and conducting experiments, we can gather data that supports or refutes our hypothesis and use that data to draw conclusions about the phenomenon we are investigating.